Hi Year 9, this is the second video for our topic of volume. In this video we're going to look at volume of prisms. So last lesson we covered units of volume and units of capacity and how to convert between them. So let's start with a couple of definitions. A prism is a solid shape and it has a uniform cross-sectional shape. So you can see here, anywhere I slice through this prism I'm going to see the same triangle, and this gives it its name. This is a triangular prism. The other thing is that other than the top shape and the base shape, the other three sides are all going to be rectangles. Now there are two types of prisms. There's a right prism and it has all of its adjoining faces perpendicular to the base shape. And there's an oblique prism and it's slanted. And we're not going to cover this one in this course. Now we can find the volume of any prism by multiplying the cross-sectional area by the height of the prism. So here we have a trapezoidal prism, and the area of the trapezium is 20 centimeters squared, and the height is 4 centimeters. We're going to use this formula. Volume is equal to the area of the base times the height. Now when I say area of the base, I mean the cross-sectional area. That doesn't look like the base, does it? The base looks like the rectangle down here. So I just want to clear something up. Suppose we take this trapezoidal prism and we flip it up on its edge like this. Then this is the area of the base, and it's the same cross section all the way through, and that's 20 centimeters squared. And the height here is 4 centimeters. So all we do is 20 times 4, which is 80 centimeters cubed. Now if the solid shape is not a prism, but it has a uniform cross-section, like this one, we can still use the same formula. In this case we have a uniform cross-section, looks like an oblong shape, it goes all the way through. So the area of the base is 9 centimeters squared and the height is 4 centimeters. We just multiply those two numbers together. 9 fours are 36, so our volume is 36 centimeters cubed. Now there is a formula for the volume of a rectangular prism. It's length times breadth times height. Here's an example. We have a rectangular prism with length 1.6 meters, breadth 0.5 meters, and height 1.2 meters. And so we go 1.6 times 0.5 times 1.2, which is 0.96 meters cubed. Now how about a triangular prism? Remember how the area of a triangle is half the area of the rectangle around it? It's the same with a prism. See the rectangular prism there and how the triangular prism's half of it? So I'm going to use the same formula, length times breadth times height, but I'm just going to do a half of it. So I'm going to do a half times 6 times 4 times 5, which is 60 centimeters cubed. Now that's all very well for rectangular prism and triangular prism, but what about other prisms? If the cross-sectional area is not given, like this one here, we need to calculate it first and then multiply it by the height of the prism. So here we've got a trapezoidal prism and we've got all the measurements we need for the trapezium, and this is the height of the prism. Let's just redraw it with the trapezium on the base so that you can see that that actually is the height. All right, firstly, we've got two steps. So firstly, we need to work out the area of the trapezium. Here's our formula. It's height over 2, and then in brackets a plus b. And remember, a and b are the parallel sides. Now this height is referring to the height of the trapezium, not the height of the prism. So it's going to be 5 over 2, 7 plus 10 in the brackets, which gives us 42.5. Now all we have to do is do the area of the base shape times the height. So 42.5 times 4, which gives us 170 centimeters cubed. All right, we'll finish off with a practical example. Our classroom measures 12 meters by 8 meters by 3 meters high. Find the volume of the air in the room. Okay, it's a rectangular prism, so we're going to do length times breadth times height, which is 12 times 8 times 3. Order is not important, and it gives us 288 meters cubed. If we want to air condition the room, it's going to require 40 watts per cubic meter. What size air conditioner is needed? So we've got 288 cubic meters, and each one of those requires 40 watts. So we want 288 lots of 40, which is 11,520 watts. Now it doesn't tell us how to give our answer, but this is fairly large. I'm going to convert it to kilowatts by dividing by 1,000. So it's 11.52 kilowatts. Okay, that's it, short and sweet for this lesson. Our next lesson, we'll look at volume of pyramids.